Hi students, up to now we had discussed the reactions of phenols and still we are going to discuss the reactions of phenols that are very important in this session. Among these, the reactions of phenol, for any of the objective questions also, there are two main reactions, named reactions that we are going to see in this video. One among them is the Kolbes reaction. What is the reaction here? Kolbes reaction. Very important named reactions we are going to discuss in this video. So let us start the concept. What is a Kolbes reaction? Whenever we get this word, immediately we must be striking the point. Phenol is used to prepare salicylic acid. What is the main concept in this reaction? Phenol is used to prepare salicylic acid. In the previous video, we had also discussed what is the importance of salicylic acid. It is used as the aspirin. So, how are we going to prepare this aspirin from the phenol? It is not a direct single step. In the organic chemistry, we do any of the reaction in many sub-step processes. So for that we want the reagents. Means reagent is the compound that is added for the reactant to get the product. These reagents will be used in a step-by-step process. We will be observing the basic equation first of all. How to get salicylic acid from the phenol. That is used for only the examinations, the board examinations. But for the objective purpose at times we may be needed the mechanism also. So in this video we are going to discuss the basic PU examination or the any board CBSE board examinations, step by step process as direct step. Later also we will be discussing the mechanism that is useful for the objective. Let us see how to prepare salicylic acid from the phenol. Basically, we are going to react the phenol with sodium hydroxide. In the initial step, we are going to react phenol with the sodium hydroxide. We have already discussed phenol is more acidic. Its pK value is around 10, and due to this it is going to react with a base like sodium hydroxide. What happens when an acid and a base reacts with each other? They forms the salt and the water. Here generally we say that is the salt and water. In this case sodium is going to displace the hydrogen present on the phenol, and the remaining will be forming the water. We can remove them in the form of the water. The OH and hydrogen are being removed in the form of the water. Sodium is going to displace the hydrogen. So it is going to form an intermediate that is called sodium phenoxide ion. We had already formed the sodium phenoxide ion in the previous equations. We have discussed how phenol will be reacting with sodium hydroxide. The purpose is this sodium phenoxide ion is more stable than phenol because this is readily involved in the conjugation. When the conjugations are increasing, residing structures are increasing, stability of the molecule will increase. Now for this sodium phenoxide ion, we are going to add carbon dioxide. One more reagent that we are going to add is the carbon dioxide, followed by acidic medium reaction. We are going to use any mineral acid that is going to produce H plus ion, so that this carbon dioxide is going to be added for the sodium phenoxide at its ortho position. Which position? Ortho position. So let us see. It is forming COOH, and the acidic medium reaction will displace the sodium on the sodium phenoxide ion. Now, what is the product we got? It is called as the salicylic acid. For any board examinations, that is CBSE examination or the Karnataka board examination, any board of the examinations, if they ask you the Kolbes reaction, the concept behind this is to prepare salicylic acid from the phenol is the main concept, and these are the steps that we will be carrying in a direct process. But now we are going to observe the mechanism. In the board examinations, you need not want to write the mechanism. It is only to understand how the reaction is going to take place. Don't forget that the phenol will involve in electrophilic aromatic substitution reactions. What are the kind of reactions the phenol is involved in? Electrophilic, aromatic, the aromatic electrophilic substitution reactions. It is an aromatic compound. It is going to involve in the electrophilic substitution reactions. What is the electrophilic means? Here the entering group is an electron deficient group. Entering group is electron deficient group. Do we know what are electron deficient centers? We had learned in the first year. Reaction intermediates. Reaction intermediates. In them, we have discussed the carbon will be generally having 4 bonds around it. 4 bonds means how many electrons? 8 electrons. So we say it is a stable octet configuration for the carbon. But the reaction intermediates, we have discussed about the carbocation. What is a carbocation? It is the one in which carbon is going to bear a positive charge on it. In this case, around carbon there are only 6 bonds. 3 bonds means 6 electrons. 6 electrons are lesser than 8. So it is an electron deficient intermediate, carbocation. Again, we have also discussed the carbon having a single electron with it and 3 more bonds. We had pointed out that one as the carbon free radical. What is that one called as the carbon free radical? Carbon free radical. Now in this case, 1, 2, 3. 3 bonds are there, means 6 electrons are there, and a single electron is also there. It is having a 7 electrons around it. So it is also an electron deficient center. Now we are going to study a carbon that is going to have only 2 bonds with some group of atoms like chlorines are given here. 2 bonds means 4 electrons and 2 free electrons it is having. These 2 are free electrons. So how many electrons it is having now? 6 electrons. The carbon with 2 free electrons and 2 bonds, it is going to call as the carbene. What is going to be called as the carbene? Okay. So this is the new intermediate that we have done today. So the electron deficient intermediates are the carbocation, carbon free radical and the carbene. So any of them will be there in the reaction mechanism. So let us see what is the mechanism here. So let us see the mechanism of Kolbes reaction. Now, what are the reactants we have chosen? We have chosen the phenol as the reactant children. For the phenol, we have added sodium hydroxide. We already discussed that the sodium is going to displace the hydrogen on the phenol to give sodium phenoxide ion. Sodium phenoxide ion. Now, this sodium phenoxide ion, this will involve in the resonance. This will involve in the resonance. Let us see how is it going to be involved in the resonating structures. The phenoxide ion can be represented as O minus, because as this is involved in resonance, it will have more stability. So we will not use directly phenol, but we will use sodium phenoxide ion that is having more stability here. It is involved in conjugation with the benzene ring that makes the pi bond to migrate onto the ortho position. Now there is an electron rich center at the ortho position. That is the carbo anion is the electron rich center. Here, once we add the carbon dioxide, two electron groups are present around the carbon. We cannot say electron groups, highly negative atoms around the carbon. Carbon electronegativity is only 2.4, that is around more than 3. So carbon is less electronegative element than the oxygen. So it is going to develop a partial positive charge on it. Which is going to develop a partial positive charge on it? Carbon is going to develop a partial positive charge on it. Means we can say it is going to act like an electrophile. What is an electrophile? Electron liking species. It needs the electrons. So the negatively charged carbo anion is donating its electrons to this electrophilic carbon dioxide. Carbon dioxide. Now the carbon will migrate the pi bond onto one of the oxygen, resulting double bonded oxygen. Here we got a double bond with oxygen and then negative charge on the oxygen. Please don't forget, on the phenol, on every remaining carbons there are hydrogens. What are present? There are hydrogens. On the ortho position also we had one hydrogen. What do we had? One hydrogen. This carbonyl group, the carboxylate group, carboxylate ion, we can speak. It is an electron withdrawing group. It is withdrawing the electrons towards to it. Hence, this carbon is experiencing the negative inductive effect. So, it is withdrawing the bonded carbon hydrogen bond. The carbon will take up the bond from the hydrogen and that will make these two electrons to be bonded between the carbonyl group and the carbon. Remember, an electrophile was introduced into the reactant and another electrophile must be removed because the phenol is involved in electrophilic aromatic substitution reactions. So this is going to be the leaving electrophile. Which is going to be the leaving electrophile? H plus is going to be the leaving electrophile. carbon will withdraw the bond from the hydrogen and this will be removed in the form of the H plus ion. How is it removed in the form of the H plus ion? Now there is a new bond between the carbons, these two carbons, which makes the pi bond to shift on to the oxygen. There is a carboxyl ion, now there is the phenoxyl ion back, but the removed H plus ion that is going to be going outside will be taken up by the O minus of carboxyl ion and that will be forming COOH. It is forming the COOH. See, this negative charge will be given to the H plus ion as it leaving outside and that will take up that hydrogen. Now the remaining negative charge present on the phenol, when added by the H plus ion, in the starting we have discussed, after adding carbon dioxide, we will be adding the H plus ion. That will be given for this phenoxide ion, forming OH, COOH. What do we call this as? Salicylic acid. So this is what the mechanism under the reaction of Kolbes reaction. So let us see the next most important reaction now. So let us see the next very most important named reaction, children. This is called Riemer, Riemer-Tiemman reaction. Riemer-Tiemman reaction. What is the Riemer-Tiemman reaction? It is going to say that phenol is going to be converted into C double bonded OH. Previously we had discussed there is one more oxygen, there is a carboxylic group, but there is only aldehydic group here. So what do we call the name of the compound? It is called as the salicylic aldehyde. What is this one called as the salicylic aldehyde? Our task is to convert phenol into salicylic aldehyde. So let us see the basic equation that is used in the board examinations. Next we will see the mechanism useful for the objective. So what is the basic equation here? Initially phenol will be reacted with sodium hydroxide. When phenol is reacted with sodium hydroxide, we will be forming the sodium phenoxide ion. What do we will form? Sodium phenoxide ion. Now we are going to add the remaining reagents. One of the reagents is called CHCl3. May the name of the reagent, children? CHCl3. It is called as the chloroform. CHCl3 is called as the chloroform. After adding the CHCl3, we will be adding the aqueous or the diluted sodium hydroxide. What are we going to add? The diluted sodium hydroxide. Once we add them, we are getting an intermediate. Here also the reaction will take place at the ortho position to the sodium phenoxide. This group of atoms, once we study CHCl3, there are 3 chlorines attached for the carbon. On the ortho position, there is one hydrogen, phenol. Okay. Now, what we are going to speak is this group of atoms are going to take the place of hydrogen. Means this entire part is going to be entering into the reaction as an electrophile. It is going to enter into the reaction as an electrophile. And the hydrogen will be substituted because this is a leaving electrophile, this is the entering electrophile. So this is going to make this reaction as an aromatic electrophilic substitution reaction. This will enter into the reaction as an electrophile and the hydrogen will be leaving as an electrophile. So at that position, at which position? At the position of hydrogen, now there will be the group of atoms CHCl2. What is that one? CHCl2. It is the intermediate. It is the intermediate in the reaction. Sir, here 3 is there, no sir. There 2 are there, no sir. Sir, do they will be leaving as chlorine and hydrogen, sir? Yes, these are some doubts that will be raised. But after seeing the mechanism, your doubt will be clarified. Now, for this intermediate, we still add sodium hydroxide. Once we add sodium hydroxide followed by any mineral acid, that is going to give H plus ion. The sodium hydroxide will make the CHCl2 group as the aldehyde group. As the aldehyde group, that is 3 double bonded OH group. The H plus is going to replace the sodium and that is forming the phenoxide into the phenolic group. So that is what we will prepare the salicylic aldehyde. This is the basic equation used for any of the board examinations. For the named reaction, Riemer-Tiemman reaction. What is that equation once we recall? Phenol when reacted with sodium hydroxide is going to form sodium phenoxide ion. When reacted with chloroform formed by aqueous NaOH, there is an intermediate with sodium O minus Na plus CHCl2. When further reacted with sodium hydroxide and in the presence of H plus, it is going to form salicylic aldehyde. This is useful up to the board examinations. But let us see in detail the mechanism of the Riemer-Tiemman reaction used for the objective purpose. So let us see the mechanism of this Riemer-Tiemman reaction, children. What is the mechanism here? We are going to break down all the process and we are going to learn the stepwise study of a reaction is called mechanism. The step-by-step study of a reaction is called as the mechanism. Okay. Now, initially in the first step, we are reacting phenol with sodium hydroxide. That is going to form sodium phenoxide ion. We have discussed this one many a times. What this one form? Sodium phenoxide ion. Sodium phenoxide ion. Okay, this is the first step that was taken place. Now, let us make the second step. The second step in the mechanism is for this sodium phenoxide ion. What are the reagents we had added? We had added the chloroform in the presence of aqueous NaOH. Yes or no? So the chloroform, once we study here, it is the arrangement of the chloroform, the carbon trichloride. Carbon trichloride. Chloroform. Now let us observe in this the carbon is bonded to 3 electron withdrawing atoms, that is chlorine atoms. These chlorine atoms are withdrawing the electrons towards them by the minus I effect. Hence they are making the carbon to withdraw the bond from the hydrogen. So this is we call as the acidic hydrogen. What do we call it as the acidic hydrogen? That is going to leave in the form of H plus ion. Whenever this will happen means once we add the sodium hydroxide. Once we add the sodium hydroxide, then only this is going to dissociate into Na plus and OH minus. The OH minus is going to give the electrons for the H plus ion. Is going to give the electrons for the H plus ion, and that is going to remove in the form of the water H2O. But here what we speak is the OH group is giving electrons for the H plus. So that is removed out. Why I am indicating this as H plus means, please observe the bond. This bond will be withdrawn towards the carbon. Means hydrogen is not having any electrons. Now this carbon can put it as the C minus. How have we written as the C minus? In this one, the carbanion is an electron with synchrony, because equal we have 1, 2, 3. 3 bonds means 6 electrons. There are 2 more. Totally 8 electrons it is having. Precise. But negative charge is an electron with center. The chlorines also will have free electrons on them. So overall, in this molecule, what is going to happen is there is the repulsion between these electrons that are present in excess. Now this chlorine is going to take out its electrons and leave the bond in order to have a stability. In order to have a stability with the repulsion of free electrons. When it is going to withdraw its electrons, completely electrons, we are going to represent here as the carbon is now with the 2 chlorines, and these 2 electrons we will not represent now with negative charge, but we say these are the free electrons. These are the free electrons. The carbon with free electrons we call as the intermediate carbene. What do we call it as the carbene? How many bonds are there around the carbon? 1 and 2. 4 electrons and 2 more free electrons are present. Totally it is having only 6 electrons around the carbon. So this is an electron deficient center. What is one? An electron deficient center. So can you call the electron deficient center as the electrophile? What do you call it as the electrophile? Now this is the electrophile in this reaction. What is electrophile in the reaction of Riemer-Tiemman reaction? Reaction intermediate in the Riemer-Tiemman reaction is the carbene. It is the carbene. So let us see the step 3. In step 3, we know the sodium phenoxide ion, it is involved in the resonance. Phenoxide ion is involved in the resonance. The phenoxide ion is giving the electrons to the benzene and making the ortho position as the electron with center. Making the ortho position as the electron with center. Now there is a double bond between oxygen and carbon. A negative charge at the ortho position. Here also there will be one hydrogen. On every carbon here there will be hydrogen except on the substituted carbon. Now this ortho carbon having a negative charge, it is the nucleophile species type. It is going to be the electrons for the electrophile of the carbene. Electrophile of the carbene. Absorption, the electrons when donated to the carbon, here it is going to form a new bond between carbon and carbon. What was formed between carbon and carbon? New bond was formed between carbon and carbon. And now These two electrons now becomes as the negative charge on the carbon. The two electrons present on the carbon will be now forming back as the negative charge. But observe the ortho position hydrogen. This is the electrophile that was added. Electrophile that was added. Now we need to remove the electrophile. This is the electrophile added. We need to remove the hydrogen as the electrophile. This is the removing electrophile. Or we can say leaving electrophile. That is the entering electrophile. This is the leaving electrophile. How to remove this electrophile? Please observe the bond between the carbon and hydrogen will be taken up back because the chlorines are electron withdrawing groups. They are withdrawing electrons from carbon. In return, carbon is withdrawing electrons from the nearest carbon. So this carbon is going to withdraw the electrons back from the carbon. That results in the migration of pi bond back onto the oxygen. That results in the migration of pi bond back onto the oxygen. Now there is a double bond here. And we observe the hydrogen is generally left in the form of H plus ion. But what did we got here? We got a carbon with negative charge. The negative charge will be given for the H plus, and now there is a bond between the H plus that was left and the negative charge on the carbon forming CH. Because the carbon hydrogen bond is withdrawn, it is returned back with carbon and carbon. Pi bond was shifted onto the oxygen. We add once again the sodium hydroxide. What did we add here once again? The sodium hydroxide. It is going to displace one of the chlorine by the nucleophilic substitution reaction. We are going to write the step in the above place. Okay, let us continue here to the above part. OH is going to displace the chlorine, and what is the product that is going to be formed here? O minus C OH, a chlorine is there and a hydrogen is present. Please observe the negatively charged oxygen is going to take up the hydrogen that is present on the carbon in the form of alcohol. It is going to give electrons for the hydrogen because this is a nucleophile now, electron rich center, and it is acting as an electrophile because oxygen is going to withdraw the electrons from the hydrogen. So the negatively charged oxygen is giving electrons for the H plus, and now the oxygen, we can observe it is left behind. It is left behind in the form of O minus. This oxygen is left behind in the form of the O minus. This is an nucleophilic center. We had already discussed. Whenever any negative charge is present and the halogens are present, there will be the repulsions between the electrons. There will be the repulsions between the electrons. This negative charge will come in bonding with the carbon, making the chlorine to be leaving out of the reaction to reduce the repulsions. And now we have our compound OH, C double bonded O, and a hydrogen. Yes or no, children? Here the chlorine had left in the form of the Cl minus. What is the name of the product we call here? We call the name of the product as the salicylic aldehyde. So this is the very important mechanism, but in the entire mechanism we want the reaction intermediate. The reaction intermediate in the Riemer-Tiemman reaction is carbene. Okay, thank you children.